It's like this. Salts is a continuation of acid and bases. So there are these things out here that you need to know. There is something in the first few chapters you need to talk about. I mean, you need to refresh, which is the preparation and separation. Okay, the separation and purification of salts. Like those uh techniques like crystallization,
Titration,
crystallization,
filtration,
filtration, dissolving, all this you have to be able to recall.
titration.
Yes, that too. But titration is new. Okay. So
That's sodium, potassium, and ammonia.
uh, all those. Okay. So titration, okay, those you is later on, but you have the very basic ones, which is the dissolving, crystallization, filtration. That one you must know. Yeah.
The separation techniques.
Yeah. So that one. Then, so you have the salt definition. So, salts are ionic compound. You know what ionic compounds are. Then you know what cations are, what anions are. So cation means it's positive ions. And then anions are negative ions. So how they are formed is a bunch of words down here. They say you have a metallic ion and or an ammonium ion replace one or more hydrogen of an acid. Yeah. So what it means is like this, you have the base and then you have the acid here. So in your acid, there is hydrogen, this hydrogen ion. So the metal ion from here, where the reaction takes place, this zinc ion will replace the hydrogen ion here. So it replaces this one. So what happens is it kicks out the hydrogen and then the zinc goes in and forms this. Then the hydrogen will then recombine with the other parts, other reactants, like other ions like this to form water. So the metal ions goes in, replace the hydrogen, then you'll get a salt here, like that. So in this case, zinc replaces two hydrogen ions in the acid. So then, so I go to the salt directly, and you will see that this is the positive ions in the ionic compound of the salt. Yeah, the salt. Then this is the negative part. So you see that the positive part comes from the hydroxide, the zinc hydroxide. That means it comes from the base, it comes from the carbonate, or it comes from a metal. Then the negative ions always come from the acid. The emphasis is given because later on preparation of salts, we have to talk about it again. So positive come from the base, metal, and carbonate, and then the negative one come from the acid. So there's this thing called water of crystallization. So when salts are formed, there are two types of salt. One is hydrated salt and one is anhydrous salt. So when your salt ions, right, combine with water molecules here, they will get all these water molecules are called water crystallization. Then when you have water crystallization amongst the ions, the salt ions, then you'll get a hydrated salt. If you don't, then it's at a hydrosol. So you have copper sulfate. Copper sulfate is present in the hydrated form and the anhydrous form. So they have different appearances. So this one appears as crystal form and this one appears as powder form.
The hydrated copper sulfate, the formula is CuSO4 plus H2O.
CuSO4 dot something H2O, XH2O. X, I don't know what's the number right now. So different crystals will have different amount of water crystallization. So when copper sulfate loses its water crystallization, then it will become the white powder. Then when it's like this, right, then its formula will be just like that. So there are experiments to show you that this process is reversible. Say like you can add water to anhydrous copper sulfate, then it will become blue again. So it has become a test for water using anhydrous copper sulfate. But I didn't think it's in syllabus, so just additional info. So to prove that people made this experiment, did this experiment. So they have copper sulfate and then they heat it. So when they heat it, right, the water of crystallization will be driven off. We get rid of the water crystallization. So when the water disappears, then it becomes white. So there's such a thing called water crystallization in crystals. So there is this thing that you need to know. I mentioned it during our first lesson, I think. So there are a bunch of salts that are soluble and the rest are not. Most of the salts are soluble because they're ionic compounds. So the ones that are not soluble, they're all exceptions. They're exceptions. So your spent sodium, potassium, ammonium, and nitrates, these are all soluble salts. So you can have sodium carbonate, you can have sodium nitrate, you can have sodium sulfate, you can have sodium chloride. They're all soluble because it's a sodium salt. Same goes for nitrates. You can have lead nitrate, it will be soluble.
Magnesium nitrate.
All soluble.
Magnesium nitrate.
Yes, any nitrate is soluble. Then chlorides, right? Most chlorides are soluble except for that two that's mentioned down there. There are more that are insoluble, but it's not within your syllabus, so we shall just ignore them. Therefore, sulfates is the same. You have calcium, barium, and lead sulfate that are insoluble. And lastly, you have carbonates. All carbonates are insoluble except for sodium, potassium, and ammonium carbonate. So this table is a must know because later on, if you don't know this, you don't know how to do preparation of salts. So there are techniques down here. We need to do a recall. You have to recall what filtration is. You have to recall what evaporation and crystallization is.
Filtration is the separation of a mixture of a solid and a liquid.
So filtration will be something like this.
solid and liquid.
So you have a mixture of solid and liquid, like you say. Then you have a filter funnel stashed with filter paper. Then you have a conical flask. Then you just put the funnel on into the conical flask. Then you pour whatever that is your mixture, and then you just pour it here. The solid will be trapped here, and the liquid, which is the filtrate, will be here. Like that. So you have evaporation. So evaporation, what you do is you separate water from maybe a salt. And then this salt must be stable to heat. Stable to heat means it does not decompose on heating. What you do is you will heat it here, and then the water will evaporate. Then at the end of the process, you will have all the salt powder at the bottom. Then you just take a spatula and scrape out all the salt, and then you can collect it like that. That is evaporation. So crystallization starts from, actually crystallization starts from this step. Step 2. Assuming you already have a solution. You already have a solution. So you take the solution and you evaporate it until maybe say you are left with like half of the solution, where they might call this point where the solution becomes saturated. Okay, so when it's saturated, you take it out from the flame and then you allow it to cool. Once it cools, right, the salts will just, the salt crystals will appear, and you can just scrape it out, put on filter paper and dry it. That's crystallization. This is usually for salts that, okay, salts where you want crystal form, you want crystals, and the salt will decompose if you heat it strongly. So this is when you use crystallization. So these three methods will be heavily used in whatever you do later on for your salt preparation. So you can fill up the blanks. So like that. Okay. That's sulfate. Okay. 6. So salt preparation, you have 1, 2, 3, 4, 5 methods. So you told me about titration, which is the first one. Then you have acid plus bases, where this is insoluble. And then this is insoluble. And the metal is obviously a solid. Then the last part is precipitation. The method 1 to 4 is used to prepare soluble salts, and method 5 is for insoluble salts. Okay. Okay. Then you also, then the whatever steps you have just now for from the recall is all here. Dissolving, filtering, concentrating, and crystallizing. So if you have those questions where you have excess insoluble base, insoluble carbonate, insoluble and metals, right? uh, this is the usual method to obtain the soluble soap. So what you do is you have the acid, then you have the base, the insoluble base, insoluble carbonate, and metal. You just throw inside. You just throw it in. And you put a lot of it. You use excess. Then you keep stirring until no more solid dissolves. Then you will put that mixture through a filter funnel with filter paper. So which is the method just now we talked about. Then the excess solid that you introduce here will be caught on the filter paper. And the liquid salt, the solution, the salt solution will flow through and then collect here. So what you do is you take this and then you heat it until it becomes saturated. Evaporate until you have a saturated solution. So once you have a saturated solution, you take it out and then you just leave it there and wait for the sugar, the salt crystals to appear. So you see that this method here, right, the step last here, this step and this step appears very often in salt preparation. You must be able to describe the steps. That's the thing. So I'm describing all the methods you can use. Then after that, then we start, then we will apply all the knowledge of this and see what method, so what methods to use for what compound. So yeah, titration, which is your method 1. What is titration again? We were talking about it a lot just now. So titration is used to prepare soluble salts. And you react acid and alkali. Sometimes you can use soluble carbonates as well. Sometimes you use soluble carbonates too. So it's divided into 2 stages. You do titration. Then after that, you repeat the whole titration without the indicator. So the example that is given, right, is to prepare potassium nitrate from potassium hydroxide and nitric acid. So drawing is here. So you need to know the apparatus name. So this is a pipette and this is a burette.
Then need to use the pipette filler.
So yeah, so you take a pipette and then you take the base or the alkali, you say. So you collect 25 cm cube of the potassium hydroxide. Then you throw it into the conical flask here. Then you will drop a few drops of indicator inside here. So in this case, they use methyl orange. Then what you do is you will fill the burette with nitric acid. And it looks like that. Then you take whatever you have here, put under the burette. Then you will slowly pour the nitric acid inside here. Then you will stop when the solution just change color and it change to orange. Then you record the reading. Say once you record the reading, you will see that maybe say 23.5 cm cube is used in the burette. Okay. So maybe like that. Then after that, right, you will repeat the whole experiment again, whole process here again. Then now you don't use metal orange. So you will repeat, take out 25 cm cube again, and then fill up, pour 23.5 cm cube of acid into the potassium hydroxide. Then you will get your salt solution. So that was this. Then you prepare 25 cm cube of potassium hydroxide into beaker again. Then after that, use in pour 23.5 of your nitric acid inside. So then from here you get a salt solution. So this salt solution, you will heat it up. Then you evaporate the water to form a saturated solution, which is whatever you saw earlier. Then you will allow it to cool to room temperature, so it will crystallize. You will then filter the solution to obtain crystals. Like that. Then after that, then you dry the crystals by pressing between a few pieces of filter paper. That is titration. They will expect you to write all the steps if they ask you to describe. Okay. So, okay. So I have one question for you. So what is the name of the salt that is produced in this titration again?
Potassium nitrate.
Okay. So what if I want to produce ammonium chloride using titration method?
Chloric acid.
So what should I use?
Hydrochloric acid.
Okay. So I'll change hydrochloric acid into which apparatus?
In the burette.
So hydrochloric acid here.
The ammonium hydroxide. In the pipette.
Ammonium hydroxide. Then
Put the pipette with 25 cm cube of ammonium hydroxide into a conical flask.
yes, then
Add 2 drops of indicator to the ammonium hydroxide.
yes, good.
Then add hydrochloric acid slowly from the burette until the solution just turns orange.
Okay. Come on. Record the volume of hydrochloric acid
The volume
used.
of hydrochloric acid used.
Then after that,
Then repeat it without the indicator.
Then some more. Any more?
The solution to evaporate water from the saturated solution.
So in this case, you will write from the ammonium chloride solution. Then allow the hot solution to cool at room temperature so that ammonium chloride crystals can crystallize. Then filter the solution to obtain the ammonium chloride crystals. Then rinse with distilled water, then you are done. Something like that. So method 2, you will have acid and insoluble base. So what they have down here is the preparation of copper 2 sulfate. Copper 2 sulfate, yeah. Formation of copper 2 sulfate. What you start with is sulfuric acid and copper oxide. Sulfuric acid here, and then copper oxide. So this is easy. You have a fixed amount of sulfuric acid. Then you will pour copper oxide inside, and you pour excess copper oxide. So you pour, then you will have a mixture of copper sulfate and copper oxide in the solution. So then when that happens, then you will filter the mixture. So the insoluble copper 2 oxide will be captured, will be caught by the filter. Then you will get copper sulfate solution in the as a filtrate here. Then your crystallization start again. You see this process. Then you will heat the solution and then it becomes saturated. Then you take it out, put it out in the without the flame, and then you let it cool down and allow the crystals to crystallize. So the same steps turn out again. So this is if you add acid to insoluble base. Acid and insoluble carbonate is the same as acid and the base. So we can make use of the diagram here again. If it's a carbonate, if it's a carbonate, so what happened is you will use copper carbonate. Then the same steps will repeat again, copper carbonate with sulfuric acid, then you add excess and then you stir. Then you will end up having copper sulfate here and copper carbonate here. Then you will get copper sulfate again, and then you repeat the crystallization process. That is for acid and carbonate. Acid and metal is also the same as this. So you just repeat this, but we cannot use copper anymore as an example because copper is an unreactive metal. So let's say I use iron metal. Iron reacts with sulfuric acid, then you form iron sulfate here. And then you filter, you will get iron powder here. Then the rest is the same again. The only difference is some exceptions here is that unreactive metals such as lead or copper and gold and silver does not react with dilute acids. Then super reactive metal like lithium, sodium, potassium, calcium cannot use also because it's very violent. Then you also cannot use this method to make insoluble salts such as lead chloride and lead sulfate and silver chloride. So this is the exception. Precipitation is used to prepare insoluble salts. And it's a bit more difficult to choose the reactants A and B. So this one, right, has to go back to, okay, recall again, that precipitation, you have to make use of this. So So precipitation, you have to make use of this. So you must first know in the metal ion the positive ion come from the base and the negative ion come from the acid. So you need to keep this in mind. Then we go back to precipitation. Okay, back to precipitation. So now to form to make something from precipitation method, first criteria, the thing must be insoluble. Then second thing is you need to know how to choose your reactants. So the reactants you choose must be soluble in water. So you choose one reactant, one solution that contains the positive ion, and you choose another solution that contains the negative ion. And you pour the two of them together, then you will get the salt immediately. So in this case, the example, they prepare barium sulfate. So you must choose a solution, something something barium something. Barium something. Then plus sulfate, that means the acid that has the uh, sulfate ion is sulfuric acid. And sulfate also can come from some other salts, like you can have solutions like uh, sodium sulfate also contains sulfate ion. So you contain two solutions. So barium, a solution that has barium and then is soluble in water would be barium nitrate, because all nitrates are soluble in water. So this procedure, right, they use sodium sulfate and barium nitrate. So what they do is they pour the two solutions together. Then immediately barium sulfate is formed at the below, okay, at the bottom of the beaker. Then you stir until no more precipitate forms. Then you will filter the mixture. So once you filter the mixture, now right, you collect the precipitate, because the salt is what the insoluble substance is the thing you want. So you collect the precipitate. Then you take the precipitate and then you wash it in water, distilled water, then you dry it. Then you get your barium sulfate already. So this is precipitation.